I'll tell you one thing why. I don't divide necessarily at the beginning because it's all in one line already. And maybe when I put these together, maybe something interesting will happen. But if it starts off as a fraction, I'll move stuff around. If it's not a fraction yet, I'm not going to bring fractions in yet. Now, you certainly could. You could bring that down. You could bring that down. It's not going to change the math very much. I'm going to have x to the 4th at the bottom. But then -4 is going to make it flip again, right?
Yeah.
So here, if it's already in a straight line, I'm going to leave it that way. Now, in this step, I can start flipping things, right?
Whoa.
What do I get here? 2 cubed,
8.
8, x to the 6. What do these guys want to do? They want to flip, right?
Yeah.
Why?
Because you want to make it positive.
It's a negative power. It doesn't like it up top. Wants to be down here. Now he's happy.
Yeah.
Time.
But
How you get 8x?
2 cubed.
Oh yeah.
Yeah, cool.
Correct.
And of course, x to the 6 is still there. And he's happy there, right?
Yeah, these are the bottom.
These 15 y's don't like it. So they go down.
He's in a positive place in his life. He doesn't want to go.
Exactly, yeah. Why switch if he's happy? Now here, who's not happy?
The 8, negative
First
8,
and last.
4.
Yeah, so the 16 x's, they like it up here. But the 3 to the -4, they want to come down here. Now they're happy. And the y -8, they want to come down here. Now they're happy. Do you guys see that?
Because
Yeah.
I mean,
The not happy part, what's that about?
all right, that's just a way to remember.
It's a negative.
We know that negative powers mean flip,
Yeah.
right? 4-letter word starts with F that I can say on video. Right?
And wave to the camera.
But a way to remember, just a way to kind of remind yourself about that is, and this is silly, I agree, but it works. It's negative, don't like it up there, so it wants to flip. What I see all the time, though, is somebody has 3x and -1, and they say that's 1 over 3x. Was the 3 not happy?
No,
He was fine. What's he raised to right now?
One.
Careful. What's being raised to -1?
The X.
The x.
So 3 to 1.
The 3 is understood to be a first power, right? So the only thing that wants to flip there is the x. So it should be 3 up top, he's happy up there. The x wants to go down. So if you just keep it straight, what's being raised to a negative power, those are the only things that flip, right? Everybody else is fine where they are. Why move them? Why cause trouble? So how many x's do I have up top then?
9. No. 8.
22 x. 22.
22.
Whoa.
Because when you multiply, you add exponents.
Right.
On the bottom, what do I get? What's 3 to the 4th?
81.
81.
81.
How many y's do I end up with?
23.
23. I like it. So just, what saves your ass? PEMDAS, as always, comes in and saves your ass. When you're not sure, think back to PEMDAS. Don't do 2 times 3 because you got to do exponents first. We've known that since day 1. Please excuse my dumb ass, I'm very generous.
So it doesn't need to be in parentheses on the bottom?
No, it doesn't really need to.
Okay.
I don't know why I did that.
So if from the first step, if I make a division, it's not.
It'll work fine.
Because the same.
Because if you bring those down, you flip the whole thing, those 3's and y's will end up down here anyway. Yeah. I mean, if you flip those x's over, it's already school, that problem's done. So from the very beginning, you flip those x's over, so you get 3y² over x4. And then -4, what's it say?
Not yet.
Flip it, 4th power it. So I'd flip it, so those x's go up top, everything flips.
Yeah.
And I still have the 4th power. I still end up here, don't I?
Yeah.
16 x's, 3 to the 4th, y to the 8th.
So then flip it before you do it.
So you have options, which normally people think of as good, but here people do parts of each way. And they don't, you got to do it one way or the other, right? So you do have options here, just you got to understand why they both make sense.
So you refer to
I don't care.
solve inside the bracket before.
Yeah, that's maybe a personal preference of mine, but there's a lot of different ways to do these. Which, like I said, sometimes kind of sucks to have a lot of different ways to do stuff.
This is the easiest question to get in mistakes.
Sing.
The way you use the solution, you did it. It is the easy way not to get in
Confused.
That's the way I like it.
Yeah.
Which, again, doesn't mean anything. It doesn't mean if you do it that way, I'll go, oh, I like you more. I'll give you more. No. Whatever way makes sense to you guys. You got to make it your own.
for like an arrow down the middle, so I know when to flip it goes up.
Oh, yeah, so this guy went
All
down,
negatives.
this
Yeah.
guy and this guy, they both go down.
Always other names.
Right, there they are.
Yeah.
Okay, cool. You can do that for yourself, circle the things with negative power, put a little arrow so you know you're moving it. I love it. Alright guys, so, if there's no other questions, we're actually gonna go ahead and get into 5-2.
Okay.
Yay!
Pat said it's alright, so I'm gonna do it.
Like,
5-2, I think the worst part about 5-2, in general, 5-2 is pretty easy. The worst part, I think, is the definition. Some of you guys might remember these definitions. Like, even just the definition of polynomial itself. Right? What is the definition of polynomial? Give me an
3
example.
variables. No.
More than 2.
Poly is,
Poly is
Poly's
many.
3 or more.
And nomial is like a term. It's a name, but it's like a term. So some examples of polynomials are like 4x squared plus 2. Or the classic one is like x squared plus 4x plus 5. Right? And these have more specific names, don't they?
Yes, they do.
This one specifically has how many terms?
binomial.
So it's binomial. It's got 2 terms. Like a bicycle has 2 wheels, so binomial has 2 terms. These are still polynomials, they just have more specific names. What about this guy?
There's my 3.
Trinomial.
There's the 3.
Try.
Like a tricycle, trinomial. And the only other one that's got a special name is like this guy. And that would be like a monomial, yeah. It's got one name, like a
And
monomial.
then anything more than 3 is poly.
Polynomial, yeah. They just kind of went, okay, that's enough.
Yeah.
No quadrinomials or anything. Alright. So, I mean, a general polynomial. These are all polynomials. What are not polynomials? Let me give you some examples. Let me see if you guys can pick up on what's wrong with this. These are not polynomials. Right? So this one is definitely not a polynomial. It's kind of slaps you in the face with what might be wrong there.
It doesn't have an exponent.
This one. No, it's fine. I mean, this has a first power. This one is not a polynomial.
Negative exponent.
This one is not a polynomial.
A radical.
Okay, good. And we'll learn later that radicals are actually just fractional powers. So basically, a polynomial has got to have a whole number power on the variable, right? You see how I got anywhere from 1, I actually have 0 here. How many x's is there here? How many x's are in there?
1.
1? Where?
0.
None! So this is like x to the 0 there. So I can have anywhere from a constant and the first power on the x, second power on the x, so forth, right? I can't have anything except whole number powers. Now, why the hell did math people do that? Did we go, oh man, I'm not screwing my students over enough. I'm going to make up some definition. No, it's because if I know I have a polynomial, I know it's nice. I know I can use anything I want to for x. I know it's smooth, and that comes later when you start graphing stuff. I know it's going to go smoothly, right? This guy's got a big problem. Where's he got a problem? What domain element can I not use? What x can I not use?
0.
I can't plug a 0. That's why it's not a polynomial.
Because it's, yeah.
It's got a problem. What about this guy? He's a little hidden, but a negative power means flip, so he's got a variable on the bottom.
Bad.
So one way to look at it, one little quick definition is you can't have any variables on the bottom. But doesn't really capture all the problems. The real definition is your powers on your variables must be whole numbers. 0, 1, 2, 3. That's what a polynomial is. That's why we made the name up. If I go over, hey Fred, yeah Jeff, my fellow Fred math colleague would say, I got a problem with this polynomial. If I say polynomial, he knows all this shit automatically. I don't have to say, I'm working with this function that you can use anything you want to for x, and then when you graph it, it's nice. Screw all that. Polynomial, bam. He knows all that right there. Right? So the kind of problem you're going to see from me is I'll have a mixture of these, and I'll say which ones are polynomials, which one aren't, and tell me if it's one of these guys, right? That's the use of those definitions.
It's gonna be okay.
No. This won't be on the quiz. Now, beyond that is the idea of degree. Holy. That one's gone.
Marcus committing suicide.
Yeah, so,
Degree, right? Not the deodorant, but for example, if I have a polynomial, I can talk about its degree. So let me start off with a nice one. The degree of a term is simply the total number of variables in that term. So there's some x's in some of these, right? How many x's are there in this one?
2.
So that's degree 2. Ooh, right? Is that simple? How many variables do I see? 2. So this has degree 2, second degree, first degree,
0.
0th degree, I love it, right? Because there are 0 variables. Therefore, it is a 0 degree term. No way I can make that easier. That's all degree is. And the reason that math people made that up is so that we know if I have a 7th degree something, it's growing really quickly. Because 2 to the 7th is big, right? Or if I have a square, 2 squared is only 4. It doesn't grow very fast. So I can tell somebody I have an 8th degree trinomial. And I just told the guy like pages of shit about this function I'm working with, right? Just in that quick way. What's the degree of the polynomial?
3.
Degree of the whole thing is just the highest one I see.
Right,
2nd.
it's gonna be 2.
Second degree. Because it's the highest degree I see.
Anywhere in the...
Anywhere. Right, so degree of a term is how many variables are in that term. And degree of a polynomial is the highest degree on the terms.
Whatever the highest exponent is.
So you don't add them all up because they're not connected, are they? They're separated by pluses and minuses. I can't put them all together. It's just the highest one that I see.
So our answer, second degree.
Second degree. So I could say, what is this? It's a second degree trinomial, right? Third degree black belt. No. This is the incredibly boring karate. So what about this? Let me give you a little more interesting one. What's the degree of that first term?
7.
How many variables can you see?
10?
10.
Yeah.
You guys see what I'm saying?
The
So
highest degree is 7.
don't think degree means power. Degree means the number of variables. So I see 3 x's and 7 y's. How many total? 10th degree. Because I see 10 total variables. Are you guys with me? That's all degree is.
Right.
The second one, 6.
Yeah, 1, 2, and 4 is 6th,
And 1.
and 1. So what's the degree of the whole thing?
10th.
17.
10.
Careful.
10.
Again, the degree of the polynomial is the highest one I see. 10. Yeah. Don't add them all up because they're not connected. These are connected, aren't they? These are separated by pluses and minuses.
A trinomial. 10th.
Good, I love it. A 10th degree trinomial. Right? If you want to be very technical. This is what I mean. These are very simple, but people get a little lost in these definitions sometimes. But I want you to understand there's a reason we have these definitions, so that we mathematicians and you guys can talk to each other quickly about something. Right? Okay. How we doing? Any questions on that idea?
If you uncover the polynomials real quick, I need to finish.
Oh, sorry.
That's better.
So pretty much all we're looking for is the degree. When you-
So I'll ask you in a problem, I'll say, tell me the type of polynomial and what the degree is. That would be a problem I'd ask you. So I'd give you a problem like, John, you need this here?
Just one. Oh, this?
Yes.
No, I got that.
So you guys, tell me